Welcome back to our Intro to Linked Data using Python course. Last time we went over how to manually create collections of JSON documents from our RDF graph, from our RDF lib triple graph. And today we are going to use a JSON-LD processor implementation in Python using the PyLD library to frame linked data subgraphs as documents. Okay. So I'll paste that subject in here. And let's begin. So I've installed the PyLD package, and so we're going to import our JSON-LD processor from that. And we will simply take our RDF lib graph, and we are going to serialize it in the JSON-LD format, and then load that back into Python native data structures. So what does this look like? We can see it has a length of 6041, whatever that is. We can see what the first element is. It's this thing, it's a document. It has an ID attribute, a special @ID attribute. This is special for the JSON-LD representation. And this is the URI. And this corresponds to, in our RDF lib, our triple graph, our RDF model of this @ID being the subject, and each of the key value pairs in this dictionary, in this JSON document, being the predicate object pairs. So @type is JSON-LD standard for RDF type. And so we can see that there are two triples that say that this ID has a type of Nobel Prize, also that it has a type of this. There's a separate JSON-LD structure for denoting whether an array is actually supposed to be a list rather than just multiple assignment like this. And yeah, so we have a bunch of, we have one statement, and if we were to look at, say, the last document, we would see this. So it happens to be a blank node. So what this is telling us is that there are 6041 documents, and there are 6041 URIs that are the subject of triples, and it's JSON-LD serialization has grouped all of those into all those predicate object pairs for that subject into these documents. So here, one thing I'll do is print the namespaces that we have in our RDF lib graph, so we can see what we have. So we've bound XML : whatever to be URIs that have this as the prefix. And we have all these other namespaces which you might be familiar with from previous lessons and things that we've loaded ourselves. And this is useful because what I'm going to do is I'm going to create a so-called context for JSON-LD. This means something very specific in JSON-LD. Just like in JSON-LD, we have the @ID meaning the URI for the subject, and @type being specific for RDF :type, and @value and @language being the specific attributes for literal types. Also @data type would be the specific attribute for the data type of a literal. So in addition to that, @context we'll see is how you specify the context, how you specify these namespaces within a JSON-LD document. So here I'm taking those namespaces and I'm constructing this context dictionary, which you'll see it just maps keys and values from prefixes to the full expansion, these things. And one other thing that I'll do here that we don't have in our namespaces, but I'm going to map category to mean this resource category. Okay, so now what we can do with the JSON-LD processor is we can produce a compacted set of documents. So here I'm going to take that JSON-LD database of 6,000 documents. I'm going to compact it using this context and pass that to the JSON-LD processor. So once I do that, I have a compacted graph, and it's going to have two keys. I will highlight them here by executing this. It's going to be one dictionary with the @context and the graph, all of the triples. So if we look at the length of the graph attribute here, we see it's compressed significantly. So there are 4,000 statements in the graph, so less than the 6,000. So let's see what happened there. We'll go ahead and take 5 out of that graph, each item, and we'll print it out. And we can see what happened here. So we have our first document being this subject, this URI, the Nobel Prize for Physiology or Medicine of 1965, represented by this URI. It is of type Nobel Prize and Award, and now we see that we have this compaction given our context, so we know what these prefixes should expand to. We have more things: Nobel category, Nobel category order, these laureates. So again, this is nice because we were able to have these compact URIs based on our JSON-LD context. Okay. And we can see things like, for example, the birthplace. There are a couple of birthplaces: New York, and country USA, and these are in fact references. These are @IDs, so these are URIs that we can get more information about elsewhere in the graph. These are references. So how does JSON-LD framing work? So there's a lot to this, but I want to just dip our toes into it in this lesson, so you can just have an example of what it looks like, and then you can consult the documentation on your own, or you might have subsequent lessons, but I want this to be brief. So what does it mean to frame something? So this is compacted, but you can see that for a lot of these things, we don't have anything expanded. So for example, this birthplace, we just have the IDs. We don't have any actual values of these resources, any of the predicate object pairs of it in line, which is something we might want to do for search instead of having to traverse the graph. So here's an example of a JSON-LD frame. So it is a document. So I'm giving the @context being the context from above, and I'm saying that this is for. I want to get things that are Nobel laureates, and I want things that have a name. I want Nobel laureates that have a birthplace, and what I want to do here is, and this is using the JSON-LD framing language, I want to embed all of the attributes, the predicate object pairs of the birthplace in here, for those that match this, that happen to be of type country, and also with affiliation. when there's an affiliation that has another triple in the graph where the predicate is country, so we know that the affiliation has a country that has to just be present. It can be anything. Then we want to embed that. And there are a couple of other things that kind of help us here that I won't go into, but this is all part of the JSON-LD framing language and syntax. And so what happens when we do this? We can get a framing, calling JSON-LD frame, on our compacted graph using this frame. And so what we're essentially asking for is to have a bunch of Nobel laureate documents that have this embedding. So we'll see what that looks like. So I run that, and we can see the length of the framed graph is 713. So it sounds like there are 713 Nobel laureate documents that fit this criteria for framing. And let's go ahead and pretty print the first 5 of those. So we can see first document, laureate 1, person, Nobel laureate. Now we can see affiliation, and it includes inline that it's Munich University, and it includes inline the country information, so not just the ID, but also that it's same as this Wikipedia entry. It has labels in various languages, and yeah, birthplace, we have that there. Similarly here, affiliation, birthplace, country. I guess birthplace we don't have expanded, do we? Birthplace, right, so it's just embedding the birthplace attributes. It's not kind of going into the country, because that's not what we need. We're satisfied with the IDs of these things, but we did want to go into the affiliation country, whereas before I don't think we were doing that. Right, so here we have an affiliation, Brown University, but this may have a country, but we don't have that in our document, so we can't search for it using a document-oriented query language like MongoDB, for instance. So here we can see how we've framed the graph to extract out a set of JSON documents that correspond to things that are of type laureate, and we've expanded out the affiliation at least to the country level and its triples. And we've also included birthplace and nothing else. So we've been able to do some projection as well. You saw that in the previous example, there were many other properties here, whereas here we're requiring that the things that we include have to be mentioned explicitly, and also they all have to be present. So you have to have a laureate that both has a birthplace and an affiliation recorded. So that's the require all and explicit for both of those. So we have a nice collection of documents here that hopefully will allow us to find laureates, for example, that have an affiliation with some institution in the country that they were born in. We have this all framed out, so we can do this query very quickly and intuitively in a document-oriented way. Once we've framed out the subgraph into a JSON collection. So that's what we'll be doing next time. Right now I'm going to take this and dump out this framed collection and gzip it, and so that's in the repository for you. And next time we'll be looking at using MongoDB, the MongoDB query language, to load this collection into a system that allows you to search through collections of JSON documents as an alternative to the graph-oriented search approach of Sparkle.